process a network of locally observed GNSS data, I'm going to begin by starting a new project. Again, working in OSTN 15 coordinate system in this case. One of the points that's in the network will be the point post-processed against the OS core stations from the longer 5-hour observation. The observations in this network will be over a much shorter time period of approximately 20 to 30 minutes, given that the receiver locations are much closer together. Let's start off by importing into the project the post-processed and adjusted coordinate for the point called office. It could be imported in grid format or lat long format. It doesn't matter too much which, as long as the correct import filter is picked from the list. Given that I chose the lat long format file, I need to select PLLH code global as the importer, and in the preview panel I can see that the data is formatted correctly, so I'll proceed to import. At this stage I'm going to save my project. And then I'm going to import the GNSS data for the project. So I'll start with the data observed for the long occupation. This corresponds in time to the shorter local network observations. On the import panel, I'm going to rename the occupied position to office so that it ties in with the point with the good quality coordinate now in the project already, but everything else is correct and as it should be. Hit OK, and that data is imported. Project Explorer, if I look under imported files, I can see both the coordinate file and the T04 raw data file that was logged for the position called office there in the project. Next stage will be to bring in the more local, shorter GNSS occupations. There's 2 points, and each point is in a T04 file in this case. So I'm going to drag those to the project. Just check the measured method position and height is correct for the receiver antenna, which it is for this data. These points have been imported with control quality, which isn't required as at this point in time they don't have an adjusted high quality coordinate. I'm going to select both points and go to change this quality parameter to unknown, and then I'll press the red recompute ball at the top. Next, import the additional files required. Again, 2 T04 files for 2 logged point positions. Need to rename these for the names that will be required in future processing. Check the antenna info, bottom of quick release, height 1.5, that's all correct for this data. So I'll hit OK. I'm going to save the project. As we can see with the OS processing the core stations from a log position, it's a similar picture here where we have potential baselines that can be processed in this greeny teal colour, which indicates that the logged data overlapped in time and can be processed together. Unlike the cores processing, when it comes to processing the baselines this time, we want to process all of the baselines in the network to form vectors. Incidentally, if you want a review of the logged information, always go to the imported files section and review the information shown in the properties panel for the raw data files. And on the home ribbon here, there's also an occupation spreadsheet which details the occupation information for each of the logged data positions. Let's go back to the plan view and onto the survey ribbon, and we're ready to process the baselines. So those baselines which link to the point called office, it shows that the processing is away from office towards the other logged positions, as office has higher point quality, so that's going to dictate the direction of the processing. Solutions are all fixed. Horizontal precisions are all very small, or low, small numbers, which indicates good precision. And likewise for the vertical precision, and the RMS is down around 10 mil. Again, what you'd expect for these shorter, these logged positions with shorter distances between them. Just going to save the processing result. And a reminder now that we have the blue processed vectors sitting over the processed baselines. But if you want to see baseline processing report at any time, just pick where there's one of these lines. There's a baseline at the bottom and a vector over the top. You can pick the baseline, and from there it's possible to open a baseline processing report. It is possible to use precise ephemeris when processing data in these local networks too. So if that is required, just a reminder that it's the internet download that needs to be opened, and then depending on the time that it's elapsed since data observation, you can either pick final, rapid or ultra rapid orbit products. In this case, enough time has elapsed to get the final orbits, so we can ask for those. I need to pick the right one, of course, so I need final orbits from after 27th of November. In this case, there we are, files ready to import, and the same for the GLONASS final orbits. And import those as well. So again, looking over in the imported files section, I can see that those precise ephemeris files are in the project and listed here. I can redo the processing using that precise ephemeris now. Hit the recompute button. I'm going to clear the processing and then reprocess the baselines. So we've still got high precision with fixed solutions, but this is processing incorporating the precise ephemeris now. So I'll save those and we're ready for the network adjustment. So I can go to Adjust Network. The only point with control quality in the network is the position office. So we're going to do a minimally constrained adjustment where the coordinates for office are constrained in 2D and height, and all the vectors will adjust around this position. Okay, so the processing is completed, and this time reference factor is network reference factor is less than 1. Chi-squared test has failed. Again, it will fail if the network reference factor is too far away from 1. So in this case, the amount of error encountered has been less than anticipated. So again, let's go to the network adjustment report as with the cause processing and just see what's going on in here in terms of the estimated easting and northing error, the error ellipse dimensions, and the adjusted vectors and their standardized residual components, and then the histogram of the standardized residuals. So there's no outliers in the processing. So in this case I will scale down the anticipated error for the network and adjust once more, and this should result in a reference factor of 1 and a chi-squared test pass. And again, that would be the final adjusted result for this network with just one constrained coordinate. Of course, if there were further high quality coordinates in the network, then having done the minimally constrained adjustment, it would be possible to go back and constrain additional points to tie the network into those as well. But in this case, we have the coordinates adjusted relative to the high precision coordinate office, and these adjusted coordinates in themselves are now ready to export. So that's points L1 through L7. Export these using the export button on the home ribbon. These will be used next with total station data, again in an OSTN 15 project, so we've got the choice of exporting in grid or global, or indeed both, and then you have your options open as to which to use at the next step. But I will export in grid first. Four points selected and export, and should I decide to use the lat longs for whatever reason later on, I will also export them in lat long format too. But again, before doing that, let me just check the decimal precision. So that's units and coordinates. Yes, I just need to increase that because that isn't set in my template, so I'll just increase that to 9 decimal places and export. Okay, and those are the adjusted positions for the local network. Now, if you have a Trimble ID and you're signed in to Trimble Business Centre, let me just show you where that is. That's on the start page. You can sign in here. So if you've registered your email address with Trimble, that will be known as a Trimble ID, and you can use that email address and password that you've used to register with Trimble to sign into TBC. And if you've done that, you will then have access to the Trimble Maps function, so you can display satellite imagery or map data in the background of a project which has either a coordinate system like this, which is in OSTN 15 of course, or another published coordinate system such as UTM, HS2, or a project which has a site calibration. And there's just the mapping option. If you want to overlay the data in Google Earth and you have Google Earth installed, there's also a direct link to Google Earth here. You can export a KML or a KMZ file using the export button, but you can also go direct to Google Earth by using the button here on the home ribbon. So I can select some data to send to Google Earth. Let me pick those points, tap the Google Earth button. Got 16 objects selected, including that line work. And there's the data in Google Earth as well. So that's the completion of this video on how to import a high quality coordinate that's been adjusted against OS core stations along with locally observed GNSS raw data observations to process those together to give high quality coordinated adjusted positions relative to that reference position.